Okay, so we just finished doing a YMCA cycle protocol, and now we're going to be doing some calculations. Over here, I have the test data sheet. We got the subject, the age, their weight, the heart rate, blood pressure, RPEs for each of the stages, which we'll be using to fill out this form. We're going to do this two ways. One way is through calculations, which we see here, and then the next way will be a graphing method. First thing I need to do is I need to put in the information, working my way down the sheet. Heart rate max is determined by taking 220 minus the person's age. In this case, our 21-year-old would have a predicted heart rate max of 199. I'm going to enter the person's body mass from our sheet, 63.5. And I'm going to look at what work rates were they at for stage 2 and 4 of the test. For stage 2, they were at 2 kgs of resistance, which is equal to 600 kilogram meters per minute. In stage 4, they were working at 3 kilograms of resistance, which is a work rate of 900 kilogram meters per minute. Now I'm going to do two parts of this equation, which for submaximal stage 2 and submaximal stage 4, I'm going to plug in this information. So we got 1.8 times the work rate for stage 2, which was 600. That's going to get divided by their body mass. And then I'll add in 3.5 and 3.5, which represents the resting metabolic rate and then the metabolic cost for pedaling against zero resistance. .8 times 600 equals divided by 63.5 plus 7. It's be 24.0 mLs per kg per minute. Next, I'm going to do the SM4 portion of the equation. So I got 1.8 times 900 divided by body mass, in this case is 63.5 plus the 7. Which comes to 32.5 mLs per kg per minute. Next, I need to get the last heart rate of both stage 2 and stage 4. With stage 2, the last heart rate was 124. In stage 4, the last heart rate was 176. Notice in this case, the 176 was the first heart rate we took at the stage. This was because they had already exceeded their termination heart rate. So at this point, there was no need to do a second heart rate. Next, I'm going to calculate the slope of the line. I'm going to take my SM4, which is 32.5, and subtract SM2, which is 24.0. And I'll have my heart rate 4 minus my heart rate 2 so 32.5 minus 24 equals 8.5. 176 minus 124 equals 52. And I'll divide 8.5 by 52. Now that gives us a slope of 0.16346. I'm going to carry this information into our final portion of our equation. We're going to take SM4, which is 32.5. I'm going to add to that heart rate max minus heart rate stage 4. So working my way through this equation, I got 199 minus 176 equals 23. I'm going to multiply that by 0.16346. I'm going to add that to 32.5, which is going to give me 36.3 mLs per kg per minute as this individual's predicted VO2 max. Next, I'm going to show you how to do this using the graphing method. So with the graphing method, what I'll do is down along the bottom, I have the various workloads. Now remember, in stage 2, we were using 600 kilogram meters per minute. In stage 3, we were using 900 kilogram meters per minute. I'm going to find the intersection of those workloads and their heart rates. For stage 2, the heart rate was 124. So I'm going to come up. There's 120, 124. I'm going to put a little dot and I'm going to circle that. For 900, we were at 176. So I'm coming up from my 900 workload. And I come to my 170, 175, 176. So now I have these two dots on my graph. I'm going to take a straight edge. I'm going to draw a line connecting those two dots. I'm going to extend that line up to the top of my graph. Where this line intersects their age predicted maximum heart rate, which in this case was 199, I'll put a mark here, and I'll drop a line down to the bottom of the graph. You'll notice this falls just below 1,050 kilogram meters per minute. These are increments of 50. So at 900, 950, 1,000. So we'll go with about 1,045. Remember, our person's body mass was 63.5. So I'm going to work out the equation right here. So I'll have 1.8 times 1,045 divided by 63.5, which was their body mass. Now I'm going to add to that 7. So now, using my graphing method, I get 36.6 mLs per kg per minute. Using my first method, I got 36.3. Very close, and both of these are within the standard margin of error. So that's how we can go through and calculate an individual's VO2 max using both a calculations and a graphing method.